Alright, number 22 and 23, good old analyzing the graph. It gives us everything that we need to actually list, so that's helpful. It says, if possible, describe the shape of the graph. So start off by graphing this in polar mode, and it gives you a super nice looking flower starfish looking thing. And so the shape of the graph is that this is a rose curve, and it has 5 petals. Then we just go from there. So the domain with polar equations has to do with what values we're allowed to plug into theta, and because theta is right here inside of this cosine function, we can put whatever we want in there, so our domain is all reals, or negative infinity to infinity, or you put the fancy r that means the set of real numbers, whatever you want to do there. The range, though, is what r values we actually get out, and because cosine alternates its values between -1 and 1, there are only so many answers we can actually get for this, for r. And it has to do with this number in front. Our range is from -2 to +2. Okay, remember the smaller number goes first. The more negative number goes first. So -2 goes first, and then 2. I just adjusted, so I may not even be in the webcam anymore. That'd be awkward. Max R value is the most it gets away from the origin, which is also the farthest away. Whichever of these is farther away, that would give us, for our range, that would give us our max R value, so that's 2. The graph is continuous. If you wanted to, you could draw it without picking up your pencil. And it is bounded with polar functions. The boundedness has to do with if we could draw a circle around the graph and everything is contained within that circle, it is bounded. The symmetry here is x-axis, and we know that because it's cosine, that it's pretty likely for that to be the case. X-axis symmetry. Some of these will have, if they have x-axis or y-axis, they might have all three, but this one does not. You can see pretty clearly that it doesn't have y-axis symmetry, and so it would have to have both of them, probably to have the origin symmetry most of the time on these types of graphs. There are no asymptotes. So 1, 2, 3, 4, 5, 6, 7, 8. That's all we need to list on there. So now let's look at the graph of 1 minus 4 sine 4 theta. This was supposed to be a limosone whenever I picked this problem, but you may notice as you graph it that that did not work out. Although it is a pretty cool looking graph. I won't spoil it too much in case you haven't graphed it. I really think you should go look at it yourself. So the shape of this graph, this is a rose curve. And it has quite a few petals. They are of different length. So we can really just summarize it as it being a rose curve. The domain is all reals because we can plug in anything we want to for theta. The range is the values of r we can have. Even though this is not a limosone, we still would do the same thing. We would do 1 minus 4 and 1 plus 4, and that gives us our smallest and highest values for r. So that would be -3 and +5. Our max R then is the bigger of those numbers, so the max R is 5. It is continuous. It is bounded. You can draw a circle around it. And it has, I think this would have symmetry about the origin, but not anything else. So that's a case I hadn't seen that coming, But if you look at the first quadrant and you think about rotating it around to the third quadrant, it would look the same. So I do believe this is symmetry about the origin. And there are no asymptotes on this one. So that's a pretty cool looking graph. I hope you graphed it. Otherwise, I mean, never mind.